Quantum physics, also known as quantum mechanics, is the branch of physics that grapples with the tiniest particles in the universe, such as atoms and subatomic particles like electrons and photons. It's a fundamental theory that provides a comprehensive description of the physical properties of nature at the scale of atoms and subatomic particles. This isn't your everyday physics. It's a realm where particles can exist in two places at once, pass through solid barriers, and instantly communicate over vast distances. Quantum physics challenges our classical understanding of the world and introduces us to a host of strange phenomena that are not just theoretical curiosities, but have real-world applications in everything from electronics to encryption. It's a world that's both mind-boggling and fascinating. Now that we have a basic understanding of quantum physics, let's dive into some of these fascinating phenomena. Quantum physics introduces us to a world where particles can behave both as particles and waves, can exist in multiple states at once, and can even affect each other instantaneously across vast distances. Let's start with a concept that truly shakes up our understanding of the physical world: wave-particle duality. This principle tells us that particles such as electrons and photons exhibit not only particle-like properties, but also wave-like behaviors. It's as if a football could also behave like a ripple in a pond. This duality is fundamental to quantum physics and drastically differs from our classical perspective, where an object is either a particle or a wave, not both. Next up is quantum superposition. This is the idea that a quantum particle can exist in multiple states simultaneously. Imagine flipping a coin. In the quantum world, until you look at the coin, it's both heads and tails at the same time. It's only when you observe it that the coin chooses to be either heads or tails. This is a far cry from our classical view where objects have definite properties at all times. Quantum entanglement is another mind-bending concept. It refers to the strange correlation that can exist between particles, regardless of the distance separating them. If two particles are entangled, a change in the state of one particle results in an immediate change in the state of the other, even if they're light years apart. This spooky action at a distance, as Einstein called it, defies our classical understanding of how information can travel. Then we have Heisenberg's uncertainty principle. This principle states that it's impossible to know both the position and momentum of a particle precisely at the same time. The more precisely you know one, the less precisely you can know the other. It's as if the universe has a built-in fuzziness, a far cry from the determinism of classical physics. Quantum tunneling is another fascinating phenomenon. This is where particles can tunnel through barriers that, according to classical physics, they shouldn't be able to. It's like walking through a wall. This isn't just theoretical either, it has practical applications in fields like electronics, where it's used in devices such as tunnel diodes and scanning tunneling microscopes. Now let's talk about Schrödinger's cat, a famous thought experiment that illustrates the concept of superposition. In this scenario, a cat in a box is both dead and alive until someone opens the box to check. It's a bizarre idea, but it's a direct consequence of the principles of quantum mechanics. The double-slit experiment is another quantum oddity. When particles like electrons or photons are fired at a barrier with two slits, they don't just go through one slit or the other as you'd expect in the classical world. Instead, they behave like waves and go through both slits at once, creating an interference pattern on the other side. But here's the kicker. If you try to observe which slit the particle goes through, the interference pattern disappears, and the particles behave like particles again. Quantum teleportation is a fascinating concept where quantum information can be transferred instantaneously from one location to another. While it's not teleportation in the sci-fi sense, it's a remarkable demonstration of the entanglement principle, and could have significant implications for future technologies, especially in the field of quantum computing. Speaking of quantum computing, this is a rapidly developing field that uses the principles of quantum mechanics to process information. Unlike classical computers that use bits as the smallest unit of data, quantum computers use quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to superposition. This potentially allows quantum computers to solve complex problems much faster than classical computers. Finally, let's touch upon quantum interpretations. There are many interpretations of quantum mechanics, each offering a different perspective on these perplexing phenomena. Some interpretations, like the Copenhagen interpretation, emphasize the role of the observer, while others, such as the many worlds interpretation, propose that every quantum event spawns an infinite number of parallel universes. The debate over which interpretation is correct is still ongoing and adds to the mystery and intrigue of the quantum world. These phenomena prove that the quantum world is indeed strange and challenging, but also incredibly fascinating. While the quantum world may seem strange and challenging, it is also incredibly fascinating and holds the potential to revolutionize our understanding of the world and technology. Our journey today took us through the quantum realm, where particles can be waves and discrete entities at the same time, existing in multiple states simultaneously until observed. We discovered the interconnectedness of particles through quantum entanglement and the impossibility of precisely knowing both position and momentum simultaneously, thanks to Heisenberg's uncertainty principle. We also explored how quantum tunneling plays a crucial role in electronics, and how Schrödinger's cat thought experiment, the double-slit experiment, and the concept of quantum teleportation challenge our classical understanding of reality. Furthermore, we discussed the revolutionary potential of quantum computing and the various interpretations of quantum mechanics. The quantum world, with all its strangeness, is not just a theoretical playground. Its principles are already shaping our technology and will continue to shape our future in unimaginable ways. Thank you for joining us on this journey into the quantum world. If you found this video interesting, please give it a like and subscribe to our channel for more content on quantum physics and other fascinating topics. We've just scratched the surface of the quantum world. There's so much more to explore. Quantum physics, with its fascinating phenomena, is a limitless playground for the curious mind. We've journeyed through wave-particle duality, quantum superposition, entanglement, Heisenberg's uncertainty principle, quantum tunneling, Schrödinger's cat, the double-slit experiment, quantum teleportation, quantum computing, and the different interpretations of quantum mechanics. But this is just the beginning. There's a universe of knowledge waiting for you to discover. Books, documentaries, academic papers, they are all out there ready to quench your thirst for the quantum, so why not grab a book, or maybe start an online course? Dive into the rabbit hole of quantum physics and let it challenge your understanding of the world. Don't forget to like this video and subscribe to our channel. Your support helps us create more content like this. Until next time, keep exploring the quantum world.